Here we're going to find the greatest common factor and tell whether the numbers are relatively prime. So feel free to give it a try, please. In 5, we have 18 and 33. And I'm going to find the factor trees here to compare our common factors. 18 is 3 times 6. 33 is 3 times 11. 3 is prime. 6 is 2 times 3. 3 is prime. And 11 is prime. Two and 3 are both prime. So, for 18, we have 2 times 3 times 3. For 33, we have a 3 in our 3 column, and I need to make an 11 column. The thing that's common to all of them is a 3. So that's my greatest common factor. Now, because that's not a 1, are these relatively prime? Not so. They are only relatively prime if their greatest common factor is a 1. These are not relatively prime. Give 6 a try. Here we have 39 and 50. 39 is 3 times 13. 50 is 5 times 10. 3 is prime, 39 is prime. 5 is prime, 10 is 2 times 5. And 2 is prime, and so is 5. So, for 39, we have 3 times 13. And for 50, I have a 2, so I need a 2 column. And 2 5, so I'm going to make 2 5 columns. And if we look here, none of our columns are full, which means that my greatest common factor is a 1. 1 is always a common factor, which is why we don't always write it, but don't forget about it. So are these relatively prime? Yes, they are relatively prime because their greatest common factor is 1. They have no other factors in common. Give 7 a try. 110 and 77. This ends in a 0, so it's got 10 as a factor, so 10 times 11. 77 is 7 times 11. 10 is 2 times 5. 11 is prime. 7 is prime, and 11 is prime. And 2 is prime, and 5 is prime. So, 110 is going to be 2 times 5 times 11. 77 is 7, so I make a 7 column, and 11. Here I have a common factor of 11. So that is my greatest common factor. So are these relatively prime? Not relatively prime, because they have a factor other than 1 in common. Not relatively prime. And give 8 a try. Here we have 21 and 160. 21 is 3 times 7. Ends in a 0, so it's 10 times 16. 3 is prime, 7 is prime. 10 is 2 times 5. 16 is 4 times 4. 2 is prime, 5 is prime, but 4 is 2 times 2, and 2 times 2 for the second 4 there. 2 is prime. So we can circle all of those, and all of our branches are complete. So for 21, we have 3 times 7. For 160, I have 2, 2, 2, 2, 2, 5 2s. And a 5. See how none of my columns are filled? No numbers are in common other than 1. So my greatest common factor is 1. And again, we don't write the 1 every time, but know that that's always a common factor. So are these relatively prime? Yes, they are, because their greatest common factor is 1. So yes, they are relatively prime. Prime in relationship to each other. So both numbers are composite. We see that they have factors, but in relationships to them to each other, they only have 1 as a common factor. We can find the greatest common factor of 2 or more monomials by factoring each monomial. So 18, again, we always take our number parts first, and 28. Factor trees. 3 times 6, and 4 times 7. 3 is prime, 6 is not. 2 times 3. 4 is not, but 7 is. 2 is prime, 3 is prime, and so are my 2's. So, for 18x y squared, I have 2 times 3 times 3. I have an x and a y squared, which means y times y. For 28x squared y squared, I have a 2, I have another 2, and a 7. I have an x squared, so I put an x in my x column, and I need one more. I need 2 of them, and a y squared, so a y in each. Remember, base times itself, exponent number of times. This is x, x, y, y. This is x, y, y. Now, what I have common to all of them is a 2 times an x times a y times a y. So 2x, y times y is y squared, is my greatest common factor. Now, find the greatest common factor of the monomials. Give 10 a try. Here we have a 6 and a 15. We always try and factor our number parts down first. Using our factor tree, we find 6 to be 2 times 3 and 15 to be 3 times 5. And all of those factors are prime. So, 6x, written in factored form, is 2 times 3 times that variable of an x. 15x, in factored form, I put a 3 in my 3 column, I make a column for my 5, and I put an x in the x column. So, those are my factored forms. Now I compare them. Since I have a full 3 column and a full x column, I multiply those together, and 3x is my greatest common factor. Give 11 a try. We're comparing number parts first. So finding our factors. 20 is 4 times 5, or 2 times 10. 36 is 6 times 6. 4 is 2 times 2. 5 is already prime. 6 is 2 times 3. And 6 is 2 times 3. My 2's are prime. So are my 3's. So everything is prime. Now we can write our numbers, our monomials, in factored form. So 20 is 2 times 2 times 5, and I still have that x, so times x. 36 is 2 times 2 times 3 times 3. 2 times 2 times 3 times 3. And it's times x as well, 36x. Now when I compare, I have a common 2 times a common 2 times a common x. Here, when I multiply them, I get 4x is my greatest common factor. Give 12 a try. 32 and 6. First thing we need to do is factor our numbers. Here I get 4 times 8 and 2 times 3. 4 is 2 times 2. 8 is 2 times 4. 2 is prime, and 3 is prime. 2 is prime, 2 is prime, 2 is prime, 4 is 2 times 2. And those last branches are prime now. So when I list factored form, 32y squared is going to be 2 times 2 times 2 times 2 times 2 times y squared, which is y times itself, and 6x squared y squared. 6 we said was 2 times 3, so I put a 2 in my 2 column, and I add a 3 column. X squared, I don't have any x columns, so I make some new ones at the end, and I have a y squared, which is, again is y times y. So my common factors, my full columns are a 2 column times a y column times a y column. Gives me 2y squared. Y times y is y squared as my greatest common factor. And 13. Here we compare our numbers. I have a 7 and a 28. 7 is already prime. I can't break that down any further. 28 is 7 times 4. 7 is prime. 4 is 2 times 2. And 2 and 2 are both prime. So I have a 7xy cubed. When I write that in factored form, I have my 7, my x, y cubed means y times itself, that base, exponent number of times. Then I have 28xy squared. 28 is 2 times 2 times 7. I don't have any 2 columns, so I make them, and I have a 7 in my 7 column. An x, so an x in my x column. Y squared means I have 2 y's. Now to find my greatest common factor, I compare them. Any full column means that factor is common. So there's a common 7, there's a common x, there's a common y, and there's another common y. So 7x, y times y is y squared, is my greatest common factor. And that's all I have for section 4.2.